Representing linear relationships using tables, we're at Module 4. This is 4.1a. We can use an equation to describe the relationship between two quantities in a real-world situation. We can use a table to show some values that make the equation true. Now we're going to see the word intercept. It means to stop, seize, or interrupt in progress or course before arrival. Like he tried to intercept the mail before she saw it. So we're going to see that as the y-intercept. Y is equal to 2x plus 10 is an equation written in slope-intercept form. So we did this in the last video. For your notes, the y is the dependent variable. This is the output. That's why it's by itself on this side of the equal sign. M is the slope of the line. So in this case, that would be the 2. It's the slope of the graphed line. X is the independent variable. It's the input. And B is where the line intercepts the y-axis. It's where the line crosses the y-axis. The slope-intercept form of an equation can be written with or without a coefficient for x, as y is equal to x plus b. Look, there's no m here. There's no coefficient for x. Since x means 1x, we actually have an invisible 1 here, right here. We just don't write that one. It can be written with addition, as y is equal to mx plus b, or with subtraction, as y is equal to mx minus b, or without b, as y is equal to mx, which is the same as if it was plus 0. Since b is where the line intercepts the y-axis, where it crosses it, the line will go through 0 on the y-axis if b is equal to 0. And also, if b is equal to 0, we don't need to write it. We don't need to add a 0 to this. If m is equal to 2 and x is equal to 5, we'd have 2 times 5. And we'd have 2 times 5 here plus 0. Either way, it's still going to be equal to 10. It's still 2 times 5. Emma bought a tomato plant that was 10 centimeters tall. Each day it grew 2 centimeters. We can represent this as y is equal to 2x plus 10 to show its growth over x days. Y is going to be its total height. The 2 is the 2 centimeters it grows every day. X is the number of days it grew. And the plus 10 was its original height when she bought it. We can make a table of values and use the equation to find the value of y. We start by using 1 for x. So we would have y is equal to 2 times 1 plus 10, which means y is equal to 12. We try 2, y is equal to 14. We try 3, y is equal to 16, and now y is equal to 18 if x is equal to 4. Dave pays $75 per month for his cable TV bill. He can rent individual movies for $5 each that are added to his cable bill. We can represent this as y is equal to 5x plus 75. Y is the total cable bill. 5 is how much he pays to rent each movie. X is the number of movies he rents. And 75 is the regular monthly cost. So depending on whether he rents movies or not, how many he rents, his monthly cable bill will vary. X will not be a negative amount because Dave can't rent a negative amount of movies. And it also can't be a fraction because he only can rent whole movies. So our equation is y is equal to 5x plus 75. We make a table of values. We have x is going to be our input, that's going to be the number of movies he rents, and y is going to be our output, the total bill. If he rents 0 movies, well, then he's going to pay the regular amount of $75. We have 5 times 0 plus 75. 5 times 0 plus 75. If he rents 1 movie, well, then his cable bill will be $80. We do 5 times 1 plus 75. If he rents 2 movies, it's 5 times 2 plus 75. If he rents 3 movies, it's 5 times 3 plus 75. Now notice, these are our x values and these are our y values. We can make a vertical table. If he rents 0 movies, he pays $75. 1 movie, that's $80. 2 movies, it's $85. 3 movies, it's $90. And these X and Y values on our vertical table of values are ordered pairs, 075, 180, 285, 390. And we can plot these points on a coordinate plane. Now I wanted to cover something that I covered in my old grade 7 math playlist. Here we have y is equal to 5x plus 75. We can see that this 5 is a coefficient for x. It's also m, the slope. What if there is no number there? What if we just have y is equal to x plus 4? Well, every variable has a coefficient. Even if we can't see it, whether we can see it or not. 5x means 5 times an unknown number. X alone means 1 time an unknown amount. So there's actually like an invisible 1 here that would be our slope. Without the x, 5 is just a standalone number. It's just a 5. It's not a coefficient. With the 5 next to the x, we now have a coefficient for this variable. Every lone variable has a 1 as its coefficient. We just don't write that 1, but we know it's there. So if it has no number, no coefficient to the left of the variable, imagine that there's an invisible 1. If we saw negative x, it means negative 1x. So keep that in mind, because you're going to come across this and you're going to get confused when you see things like an x by itself and you're like, well, wait, where is the slope? Or if you see a negative x, it means negative 1x, okay? I'm going to have a link to this short video in the description, and I really think you should watch it because it's really going to help you, especially when you see negative and then parentheses. What are you supposed to do? As we move forward in algebra, this is really going to help you, this video. Okay, we're finished with 4.1a. We're going to move on to B, examining linear relationships. I hope you're doing well, and I hope you join me for the next part of the lesson. Bye.